On the Boeing 777, the ram air turbine, or in short the RAT, is located in the right side fairing. The RAT is an emergency source of hydraulic and electrical power, which automatically deploys when all other sources of the respective system fail. On modern aircraft, the possibility of the RAT deployment is very less, due to high level of system reliability. Chances are even less on the 777, as the redundancy standards of the aircraft is on another level. The RAT can deploy in 3 different situations. Number 1, total loss of hydraulic power. The aircraft has 3 independent hydraulic systems. Left system is powered by the left engine-driven hydraulic pump, and the right system is powered by the right engine pump. The center hydraulic system is powered by 2 electric pumps. All 3 systems have additional demand pumps, used when the load on the system increases. The left and right system have 1 electric pump each. The center system has 2 air-driven pumps, which runs on the aircraft pneumatic supply. Of the total aircraft hydraulic load, the left system can operate the left engine thrust reverser, left and right aileron, left flaperon. Number 2, 4, 11 and 13 spoilers, left and right elevator, and the rudder. The right system can operate the right thrust reverser, left and right flaperon. Number 3, 6, 9 and 12 spoilers, right elevator, trimmable horizontal stabilizer, and the rudder. The center system can operate the landing gear actuation, left and right aileron, right flaperon. Number 1, 5, 7, 8, 10, and 14 spoilers, flaps and slats, left elevator, trimmable horizontal stabilizer, and the rudder. When only flight controls are considered, the aircraft can be safely controlled, with just 1 hydraulic system available. Therefore, for the RAT to deploy under the first condition, all 3 hydraulic systems must have low pressure, either due to fluid leak in all 3 systems, or multiple component failure, which is unlikely to happen. The second condition in which the RAT can deploy is the aircraft electrical system failure. There are 3 main generators on the aircraft, and any 2 can meet all the electrical demands. When engines are running, the left integrated drive generator powers the left main electrical panel. Right engine generator powers the right main electrical panel, and the APU generator remains on standby. The main panels distribute power to the other electrical panels. Plus there are 2 backup generators on the engine, which supply limited power in case of multiple main generator failure. 1 backup generator is enough to run all critical loads of the aircraft. The electrical systems will shed power to non-essential loads when the power source is limited. Therefore, for the RAT to deploy, due to electrical failure condition, all the 5 generators must fail, which again is unlikely. Now let's look at the third condition, dual engine failure, and center hydraulic system pressure low. The GE90 engines are highly reliable, and rarely does an engine fail. If an engine does fail, the APU is used to support the other engine. For the RAT to deploy, under the third condition, both engines must fail, and the center hydraulic system must have low pressure. Even if the aircraft suffers dual engine failure, the APU will ensure the center and other hydraulic system pumps keep running. As seen in all the 3 situations, a lot has to go wrong in terms of system malfunction for the RAT to deploy on the aircraft. But there is one event that renders all the system redundancy useless and leads to RAT deployment. It's fuel exhaustion. If the aircraft runs out of fuel, then the engines and the APU will stop running, which means all 5 generators and 2 engine-driven hydraulic pump unavailable. With electrical powers out, the electric hydraulic pumps will stop. And as the engine and APU also provide the pneumatic power, the air-driven pumps will fail. The aircraft has suffered complete loss of engine thrust, hydraulic, and pneumatic power. With majority of the electrical system lost, the only power source available is the aircraft main battery. The main battery continues to power the critical buses of the aircraft, which helps to release the actuator and deploy the ram air turbine. The RAT is equipped with an electrical generator and a hydraulic pump, driven by the 2-blade turbine. The RAT's first priority is to provide hydraulic power to help control the aircraft. If the RAT RPM is less, then the electrical system will disconnect the RAT generator and use the aircraft battery for operating critical loads. This ensures the RAT is able to maintain the hydraulic output. The RAT hydraulic pump uses the center hydraulic system fluid, and the output is only used to operate the primary flight controls powered by the center system. That is the left and right aileron, right flaperon, number 1, 5, 7, 8, 10 and 14 spoilers, left elevator, trimmable horizontal stabilizer, and the rudder. When the speed is sufficient, the RAT will also provide the electrical power. When supplying electrical power, the RAT ensures the cockpit flight instruments and displays. Few navigation and communication systems are functioning. With no engine power, the aircraft has turned into a massive glider. The ram air turbine, along with the aircraft battery, helps make a last-ditch attempt to control and save the aircraft. Thanks for watching.